So good evening, everyone. Thank you for being here. I think we have a very esteemed panel with us today. In a minute, I'm going to ask them to kind of introduce themselves. But from what I see from this panel, there's a lot of strength, not only in AI, but also science. Clarence, has a strong AI and science background. Mike, as well in one of the questions that Jude asked in spectroscopy, so there in that as well. And Yasantha as well in the physics realm, who'll be joining us shortly. And I think this is a great panel to kind of foray into what are the possible solutions that we can build, to fight. And I look at it through two buckets, right? One is taking on COVID directly and trying to find solutions for COVID-19. And the other is a bet on the post-COVID world. What are the kind of startups or businesses that will continue to grow well and do well in that? So with those two buckets in mind, if I can start with maybe Mike and then go down. What are you guys working on? And maybe tell us a bit about your background. And what are you guys working on that is in either of those two buckets going forward?
Well, Jivan, thank you so much for inviting me today. It's honored to be on such a great panel, esteemed panel indeed. So what I'm working, hi, I'm Mike, and I'm a guest researcher at Fraunhofer IZM, and I am also a co-founder of a company called Spectrify AI, where we are going to use low-cost, broadly distributed spectrographic analysis to improve people's idea of what's happening with what they're purchasing, whether it's agricultural or other materials. What I'm working on specifically here at Fraunhofer in regards to attacking COVID is we're working on luminescence. Basically with Q and RT-PCR tests, the way you're able to diagnose COVID real time, all of these require a specific type of illuminator for fluorescence to get the sample to fluoresce at a specific wavelength. And that's what we're working on here at Fraunhofer right now. We're developing low-cost fluorescent illuminators and detectors in order to accelerate the ability to identify COVID with the current tests that exist now.
Awesome. Maybe Dr. Clarence?
Hi, yeah, thanks, Jivan, for having me here again.
You can also mention your multiple investments in companies.
Right. So I guess I'm currently working more on a social impact revenue sharing investment platform called EPIC. It stands for Exponential Positive Impact Capital. So I guess my background is really in artificial intelligence and neural network applications in finance. Really, so I was on a very dark side of industry. I was in Wall Street in the late 80s when greed was good, but I sort of I went back to academia and doing good now, I hope. Yeah, so I got Jivan interested in working on the EXO COVID challenge, and this is part of the series of the seminars we're doing to prepare people who will be interested in participating in that. I highly encourage you to do that. You know, like we can actually do something to change the world for the better. Yeah, happy to help where I can, and happy to support this initiative. Yeah, we can carry on the investment side, but yeah, and AI and other areas that I've been involved in. Thanks.
Thank you. Luciana?
Hi, everybody. My name is Luciana. Thank you for inviting me. My background is in business creation. I'm an entrepreneur, and I've been working for many years now in this space, working with the EXO framework, in fact. And along the way, you know, one of the things that I've noticed was this huge gap that there is between technical people and business people, and that great things happen when we work together. And so started to develop some technology solutions, which were really making a lot of sense to scale them and solve some of our planetary challenges. And this is actually one of the things that took me to create AI Dragons, which is a community that really strive for that, bringing together technical people with business people behind solving some of the planetary challenges that we have. And obviously, we are currently facing one with this pandemic. And I'm currently working on a self-learning and knowledge-sharing platform community, because I believe that it is crucial that we share, resources, data, and knowledge to be able to face these kind of planetary challenges. So thank you again for having me here.
Thank you, Lucian. That's a great intro. And Dr. Yasanta, I think glad we have you on the panel. I know the time difference is a difficult one. The question, we just wanted the panel to kind of introduce themselves, but also think about the type of startups that are there. One is that's fighting the battle on COVID-19, checking for infection or trying to figure out a receptor for the virus, or is your startup more on taking a bet on the post-COVID world, where there's a new normal and it's solving for that kind of problem? So, which of those two buckets are you looking at, and what is the startup that you're working on going forward?
Yeah, good. Hi, my name is Isanta. I think I'm sorry I'm a bit late. It's 4 morning, so. But I finally got on. Everybody can hear me?
Yeah, you can hear you. There's a slight breakup, but otherwise it's fine.
Echo? Okay. Yeah. So I have been working in the Silicon Valley for the last 30 years or so, and worked at many technology companies. Last 15 years I work on Wi-Fi and many internet technologies like DSL and things like that. And currently I'm a chip maker. Basically, we make 5G chips. Okay, and so very recently I've been on a project with looking at automotive radar for using inside homes for AI, right, to detect certain patterns and things of human behavior. Because people don't like microphones in their homes, people don't like cameras, for various reasons. So it seemed like that was a good idea. So we worked on that. So there have been quite a few things. I have come to Sri Lanka a couple of times and given several speeches to many before.
Yeah.
So Jeevan invited me for this particular this invitation, right?
Yeah. Yes, your audio is a bit choppy. I don't know if there's anything you can do about that, or if that's on our end. Can you just please just see what you can do? It's a bit like the audio when you're talking, the mic doesn't seem to be that clear.
Okay. Given, I think you guys go ahead. It's fine. I can hear you very well.
Okay. Fine. Okay.
Yeah. So I don't want to just crowd everybody with that audio. Okay. I'm so happy to be here. I'll be glad to offer up advice and such. But yeah.
Okay.
Please go ahead. I apologize for the audio issue.
No problem.
I might rejoin, okay?
We'll try and rejoin. We'll try and ask you choice questions, I think, because
yes. Yeah.
So I think thank you for those intros. One of the early breakthroughs has been has everyone heard of this drug called remdesivir? I think it's a drug used for Ebola. And they've been able to identify that mainly through a machine learning kind of project. And the way they did that was obviously there's a guy called Matt O'Connor who had no kind of background in pharmacology or bioscience, he would basically just use small molecule development and was able to understand the 3D structure of what coronavirus and what fits into that molecule. And I think was able to discover that this had the highest probability of success. And now there's 3 clinical trials happening. And I think there's obviously 3 spaces if you're looking at of this kind of this type of science. Obviously vaccine development, antibody development, and also kind of small molecule development. And I think maybe in those 3 spheres, obviously small molecule development seems to be probably the most easiest, at least for somebody who doesn't have a biomedical background. Are there any thoughts on using AI in any of these 3 approaches, and any learnings that the panel can share for a startup who's looking to enter this space, and looking at how you can kind of come up with solutions for this kind of thing using data science and AI?
I'll shoot with this, Jivan, if my voice is okay, if you can hear me clearly. One of the first COVID hackathons that I organized here in Berlin was data economy, and one of the winning entries was a team that used quantum tools to accelerate drug discovery. So if I was going to suggest something to any startups out there, start looking beyond the standard conventional molecular modeling tools, make a big jump and start using some of the free quantum computational tools and leverage this skill, because when you use quantum drug discovery, you're able to find potential targets and drugs faster.
Clarence or Luciana?
Yeah, I think there are. I mean, one of the first things that happened when COVID was reported, COVID-2, was that basically the data was all shared, right? I mean, it's available publicly, so you can actually be a citizen data scientist and basically work with some of these projects. And there are many. I don't know about in Sri Lanka, but there are many biohacker labs, community-run ones. It also seek some knowledge from them, and also there are plenty of databases around the world that has a lot of information on both pharmaceutical and the medical stuff that you can actually access easily. And I think Mike will probably have a list of those somewhere, right? With the hackathons, biohackathons.
Yeah, I'll get into data structures a bit more, but just to press you for a bit more information, Dr. Clarence, you're one of the first people that I heard biohacking about, maybe I would say 7-8 years ago, right? Are there any interesting use cases for biohacking, or is it still let's make that gerbil glow in the dark? And do you see any use cases for biohacking in this particular instance where we can use it against COVID, or we can create a better post-COVID world?
Yeah, no, I think that there's been a lot of development, particularly in computer simulation. And as Mike said, quantum computing space, that would actually enhance the speed of discovery of new drugs and so on. So I think the thing is that a lot of stuff now, maybe you can even just do a simulation as opposed to having to do a real physical biohazardous kind of lab instruments that you need. So because you can actually design a particular, even a DNA, and get it manufactured and send it to you, and then you can send it somewhere else for testing. So you really could be a citizen garage home scientist, right?
Wow, that's really cool. I think what you're saying is I would never have to actually make that molecule, but I can see in a virtual environment how the molecule interacts with the bio and stuff like that.
Simulation and so on. Yeah.
That's really great.
So,
Luciana, anything to add to that from maybe a community perspective? I think one of the things in Sri Lanka is and really what Hatch is trying to do is get community together and stuff like that, and get people interested in these kind of topics. Is there any advice or anything that you can offer in this? That would be great.
Well, first of all, in terms of applying machine learning and the opportunities to really, help in the COVID situation and the post-COVID, I think there are many opportunities. Obviously, biohacking and understanding what drugs could work, that's one. But I think there are many more related to, ICU prediction, but also predicting the contagions and really understand those patterns. So I think, staying broad in what can machine learning do in this case, because even, for example, companies are needing right now to predict, their supply chain much, much better, right? So even though it's health and infection thing, we need to think broader. And in that sense, I would invite the community to take that opportunity and not just to focus on all the efforts on one area. Then with regards to data collaboration, obviously is crucial. And one of the challenges that I see there is definitely how do we, make sure that the data that we have is good quality, because we know that for machine learning to really be useful, we have to have quality data. Otherwise, it's garbage in, garbage out. So, and there, I think where the community can really play a big role, And I think they should understand that in this case, it's super important to work close with the authorities, right? So that they can get a better data set. So happy to talk a bit more about the community. I think there are very nice models, and that we might need to think and introduce to find some of these planetary challenges, which would make it a bit more order, so we can get better results. But I will let the opportunity for other panelists also to interact.
Okay. Thanks, Luciana. And let's talk a bit about data. I think as we kind of discussed, right? And I think finding data is a big problem. And when I was researching this set as well, one of some of the data sets are available with COVID, and I came across this data set around connectivity maps. And basically, connectivity maps is a resource that basically finds relationship between disease, cell physiology, and the therapeutics around it. And I think this can be used by biologists, chemists, and pharmacologists for drug discovery and for also finding gene pathways, right? And I'm gonna maybe actually copy paste some of the links that I found I was just looking for this so that the people that are here can this thing. But and I think that kind of rich data is now becoming available, right? Where you're finding the relationship between cell physiology and disease. And one of the problems that we were trying to solve was predictions of rare diseases. First of all, are there any more other cool data sets like this where we have like biomarkers with diseases? I see Mike really shaking his head, so he's got to go first. And what are these data sets that startups can look at to start figuring out these hard problems to solve? I think,
Well, okay. What I recommend people start looking into is they look at the various Omec databases. So Omec is when you're talking about cell physiology and we break down a human system, we're looking at different Omec systems such as proteome, genome, metabolome. Where I have more experience is with the metabolome. So one data source I find to be very fascinating is published by the University of Winnipeg, and it's the Human Metabolome Database. So what this does is this gives you quantifiable results, knowing that if you detect a particular compound in a particular fluid of a human, for example, feces, there are 1,153 peer-reviewed studies that indicate if you find out of 1,153 specific compounds in human feces, that those directly correlate to a disease condition. So that's what's proven. There are another 3,000 that are under investigation. So by accessing these data sets for entire omic system, if you're not into the metabolome, right, that's how we eat and things come out. That's how we transform food into energy. But there's the proteome, how proteins are synthesized. So I recommend that these data sets are not specific to COVID. However, linking these data sets with COVID data will lead to significant what is Hinton using? What does Hinton use with AI? I'm forgetting the term. Like when you have the aha moment.
Correlation or causality.
No, it's intuition. Intuitions. It'll lead to intuitions.
I was going to say the British Museum algorithm.
Dr. Clarence, any thoughts on data, or Luciana, any thoughts on data and unique data sets that we can look at? Great lead in with the omic systems, which brings me another interesting point, which I'll raise up after this. Yeah.
Well, I think the validity of the data set, right? I mean, there are now a lot of suspicion on the data collected by the Chinese, right? So I guess, how do you validate that? I think, we should, in part of the challenges for this is, how do you actually make, I think that's why, I mean, a couple of days ago when we had the blockchain one, that is where blockchain could perhaps be used to essentially give you an audit trail of the data sets, make sure that the data that you collect is actually valid and not being tampered with or being contaminated somewhere, right? Because any AI algorithm you're going to build on top of it, you need to make sure that the data is robust. So yeah, I think that's my word of warning there.
Okay. Luciana, do you want to?
Simply emphasize on that, as I said before, because, and particularly because we've seen that different countries are taking very different methods to collect, to test. So I think watch out for testing, yeah, because that's really probably messing up a lot with your results. So yeah, particularly if you want to predict. But that's why I think, again, I really want to bring up, that there are many opportunities beyond just the drug discovery. Yeah, I'm going to share here the data set that was published by the European Union, if someone is interested in having a look. But again, as I said, with a word of caution that not every country has the same approach. So I think in the end, we do have a lot of challenges in data collaboration. And there is where I think, we can deep dive in what can the community play around. And of course, like as Clarence said, perhaps one way of managing that community is empowering them to participate and interact and contribute through blockchain. So this data set is more trustable. But in the end, yeah, it's also about maturing the way that we collaborate with each other, because obviously, hackathons have been on the rise lately, and they have come up with quite a lot of interesting results. But I would say, not necessarily they have evolved into a community, right? And part is because we don't have a lot of system, like for example, you would have on a Stack Overflow, where you get to see some registration of what people have contributed. There are moderators, so perhaps a thing to think about, yeah, is exactly that. How could we, create like a network of networks to where we can have that.
Okay. Yeah, something. If your mic is better, do you want to take a gander at what good data sets?
Yes. Yeah, I'm not going to turn my video on because now you can hear me better, right?
Yeah,
because
actually, that's a lot better. Yes.
Okay. Yeah, if I do turn on the video, the bandwidth issue comes in. So yeah. So basically, I think we talked about drug discovery and some of the those aspects, but I think one of the things that Sri Lanka can do is obviously there's a in diagnosis also. That's another area that we didn't talk about, right? I saw some studies by the Chinese saying that you can look at the chest X-rays, and things like that, and tell sort of the severity of the disease, or how to differentiate COVID from a normal pneumonia, right? So I think those kind of things are very accessible to Sri Lanka. The X-ray database is available, I think, in all of the hospitals, so you can even study the local demographics. You can probably, in fact, I would recommend if you can even create some data sets like that, then you can, provide that as a startup to others, and it's a very easy sort of business model. You go to hospitals and get all that stuff and put it in the right form. Okay, some low-hanging fruit.
I wasn't
Yeah,
aware
so
that data sets were available. Are those, can you, I mean,
no, foreign ones are available, right? But I'm saying if you're a startup in Sri Lanka, one of the ways to contribute is to create data sets, okay?
Yeah.
I think that's a fairly easy thing. Rather than solve the problem, actually create the tools to solve the problems for the rest of the world, okay?
Absolutely. Yeah, absolutely.
That's sort of, that's sort of a simple way to go about doing things. Yeah, so that's about for now. Yeah, go continue. Yeah.
Thank you for that. And I think just staying on the medical side, I think obviously there are trending stuff that would happen anyway without COVID, but are probably now accelerated, right? One of those I think Yasanta touched on, which is image processing, for example, in radiology. And we can think of a whole bunch, right? Virtual assistant nurses, AI diagnosis or diagnostics, clinical, increasing the clinical trial speed. And just coming back to, for example, what do you think works from a South Asian perspective? Because obviously we face different challenges from Europe, and I think touching on what Mike spoke about, Omec system, I think there's early wins where they're able to understand whether someone has breast cancer from from their residual matter. And I think there are markets that love that. What do you think is from all what I mentioned, something that can work in the South Asian system?
Yeah, I think for South Asia, actually Sri Lanka is in a decent position because you have a good workforce with fairly who's able to do some good AI, and also at the moment I think the COVID disease has not spread, right? So if you think about the country alone, then I can think of other things other than the disease part, the social distancing part, or analytics to help governments and local city governments to decide whether they should shut down or how much they should open or close the city. Like a lot of people are starting here in the US, starting they're going to try to get back to normal, but for instance, our company is only allowing 25% of the people to come, right? And they will keep changing that number, right, as a function of time. So instead of having, I see it's a tremendous, basically everyone has curfew right now, right? So the whole country is shut down. One doesn't have to do that. So you can use AI in a pinpointed, targeted way to find the hotspots and then recommend at what level you can try to kind of have a partial shutdown, right? So maybe have 2 out of 5 work days for some people, or roll them. I think those kind of strategies, I think with some big data can actually help countries like Sri Lanka reduce the cost, or not only Sri Lanka, but India or any of these other countries that don't have as many resources to be able to manage the thing better. So there's one way to another way to use AI, right? Is to again, it goes to understanding the disease map and connectivity map, but more importantly, actually, once you have the data, kind of what to do with it. Okay, so I think those are good fields to look at. Yeah. Yeah.
Luciana, do you want to go next?
Yeah, well, I just thought of what we were discussing, and perhaps Mike can share that example. But definitely, a country like Sri Lanka is going to be very important to be able to manage the resources properly, right? So before we start, Michael was telling us about this example of false alarms and how, machine learning can better predict whether an ICU alarm is really, a false alarm. So perhaps, Mike, you want to elaborate in it, because I think in those contexts where, the health system do not have so many resources and are under pressure, management of resources becomes critical. Yeah.
Oh, Luciana, that's a wonderful lead in, and thank you. So the example I would like to share with everyone is this is the data from Charité Hospital in Berlin, which is the top research hospital in Germany, one of the leading ones in the world, actually. And they found that 98% of all ICU alarms are false alarms. However, in an ICU ward, the doctor must respond to every single alarm. So start thinking about the fatigue. Our healthcare workers are more valuable than gold. They're the most valuable humans we have on this planet right now, as far as I'm concerned. We need to keep them healthy, and we need to keep them productive and happy. So there's one low-hanging fruit right there. If we can find a way to reduce the false positive alarms that attending physicians must respond to, you will increase their capability of responding to needed events. And that is something you can do in Sri Lanka. The tech is there because Sri Lanka has incredible brain power. And I'd like to drop in one other thing that could be done in South Asia. See, Sri Lanka has a unique Ayurvedic tradition. And now is the time to start taking this vast amount of Ayurvedic data you have and start looking for unique ways to treat this disease or comorbidity by using this very catastrophic event. Okay, there is a wonderful Sri Lankan medication that is used for colds. It's made by Sita-Lepa, and I forget the name of it because I'm out of it right now. And it just cured my kids, right? There's a lot of hidden gems in Sri Lankan traditional medicine, Ayurveda, and in the culture that can be used to fight COVID. Don't forget, people of Sri Lanka, that you created these wonderful tanks, your irrigation system that's over 2,000 years old, okay? So I think it's, just to sum it up, it's unleashing what Sri Lanka is capable of doing. That's how we address South Asia.
Okay. Dr. Clarence.
I think, the other thing that I would like to see is one of the reasons that was postulated of why there's such a low rate of COVID in India, given the population, was that they were given BCG shots, right, and been exposed to, somehow the TB vaccine has got some impact on it, and it's, I don't know who is doing research on that, but that seems to be true too for countries like Malaysia, and I don't know about Sri Lanka, that, where they have very high take up of BCG vaccination. So some of because I think 95% of the population in India is exposed to either the self or the vaccine, or been vaccinated for it. So I in terms of some of the unique situation, I mean, India is an interesting one, right? Because either if the reporting is to be believed, then they have extremely low rate of take up in India compared to the rest of the world.
And I think there are unique diseases as well, and unique challenges that Sri Lanka can focus on. For example, there's a high incidence of CKD here. I think, for example, that can be looked at and said, okay, how do we, can we look at solutions around that maybe AI, you can collate the data around CKD and maybe come up with a solution, then you can take out and stuff like that, right? So I think those are kind of unique things that we can do. And when I was mentioning, Mike, omic system, if you're able to detect breast cancer in your residual matter, it becomes really cheap for diagnosis, right? Because you don't need expensive equipment, to do mammograms and stuff like that. So in the South Asian context, cost is one of the main drivers, right, of adaptation. So I think we really need to look at AI solutions that have that kind of have cost in mind, as well as obviously what you guys spoke about as well, a unique use case. So just getting the startups to think about that, and I think is one of the challenges. Yasanta, do you have anything to add?
Yeah, I think there were some very good points made here. So one of the things I think we can do for Sri Lanka is that I see that I really don't know how much a test costs, but in the US, they claim like it costs like close to $1,000 a real test. Okay, but it was, but now it's probably cheaper. But these machines are expensive, so one can use AI to make models to see who to test. Okay, because obviously, if you can test everyone, it's good, right? But then some of the cases are just standard flu or pneumonia, right? And so you don't have to blow a whole test on that. Maybe AI can, you can make a model and increase the probability of sort of predicting which person probably has the COVID-19 disease or something, some other thing, right? So that would help healthcare workers a lot. So that's an area I think a resource constrained country can definitely benefit a lot, because I think most of these tests are all German tests at the moment, right? So that the World Health Organization probably gives out free right now, but at some point, countries have to pay for it, right? Because you can't do millions and millions. So that's one area. I think in terms of indigenous medicines also, I think Mike mentioned that the Samahang thing, basically the ingredients of some of these coriander, turmeric, and some of these combinations of such things are known to be antiviral, okay? Now, whether it works for COVID-19 or not, that has to be determined, but but one can probably increase or custom design even a new indigenous medicine, that is an Ayurvedic type medicine, because some of those guys just did it over the last 500 years or so, just testing it in a few patients here and there, and then seeing which one worked, right? And that's definitely, they used the scientific method probably, but they didn't publish it. They kept it for themselves, so people who know, so then people just come to you, right? Now I think there's opportunity. If any of these techniques are working, I think AI is really good, because you can cross-validate and then correlate, like I said, find causation, and then maybe you can even discover some billion-dollar drug. I think that's a very, very good area. Okay.
Yeah, maybe that's why the Chinese were eating the bats, because they thought it might be a cure for something else.
There you go.
Okay. So I think one of the things that we were discussing in Sri Lanka for a long time is clinical trials, right? There's lack of clinical trials happening in Sri Lanka, and I think maybe Sri Lanka has the ecosystem to kind of enable clinical trials and stuff to happen, maybe with its AI, ability in AI, ability, the health system is not so bad. So there was a lot of talk about enabling clinical trials, then using AI for predictive enrichment treatment, or improving investigator and site selection, for example. Any thoughts around how a country like Sri Lanka can really enable or help hasten clinical trials
So I think one thing that comes to my mind is that when you are trying to do clinical trials, right, an audit trail becomes very important, okay, because people try to fudge data, right? That's where your blockchain can come in, okay, because I don't think right now they're using any blockchain tools for even international clinical trials, right? So, you know, they do the double-blind test basically, and with the placebo. But so when you do it in a sort of a country like Sri Lanka, then basically it's important that they don't fudge the data, okay?
Yeah.
Otherwise, you end up, you know, with the wrong conclusion. So I believe maybe that's an area I'm thinking maybe one can integrate with the blockchain right away. And I think that would be an interesting product.
Any other thoughts from the panel on clinical trials? And just a quick shout out to Tisa. I think if you can ask questions around, I know you're big on Ayurvedic, questions to the panel around Ayurvedic and AI would be great as well. Sorry, to the rest of the panel on clinical trials. Do you see any possibilities for Sri Lanka to help with COVID-19 to kind of fast track some of the stuff around it?
Sri Lanka is a beautiful island nation, so you have the ability to seal your borders easier than most countries, which means you have a more control over your environment for COVID drugs and spread. So I could see that Sri Lanka actually is an ideal environment for clinical trials, especially when you're going to stage 2 and 3 clinical trials with larger populations. So these are things that Sri Lanka can take advantage of its unique geography. Now, not all island nations are going to be able to do this. Madagascar is not going to be able to do this. Frankly, Indonesia is not going to be able to do this. So it's leveraged. So how can Sri Lanka do better with clinical trials? Leverage the physical advantages you have and the intellectual capital of the country and a stable political situation. Now, some people may say Sri Lanka is not stable. I would like to compare with the peers, right? Sri Lanka is a heck of a lot more stable than Madagascar. I would even say more stable than Indonesia or other countries in South Asia. So this is a unique combination that can accelerate Sri Lanka being a base for clinical trials.
Yeah, thank you. Anyone want to add anything? Luciana, Dr. Clarence?
Yeah, I think, you know, obviously Sri Lanka has been working really well on the education system. I think what's lacking is probably the opportunity to be innovative and creative. I think technically they're very brilliant, but I think it's the next step. So I really don't see Sri Lanka, you know, doing this by themselves, but I think doing it globally and partnering up with people like Mike in Germany and you know, us in Australia or Luciana in Europe or in the US, Santa in the US. I think that's the way to do it, right? Because now with all this technology, you can collaborate, you know, pretty easily, and I think that would actually enhance the opportunity. I mean, you know, I live in a big island too, but problem is after the COVID lockdown, how are we going to, what are we going to do? Are we going to permanently seal our borders?
Yeah.
Because, you know, not everybody is doing the same thing, right? So that's a big problem. I don't think that we have resolved. I mean, you know, we have fantastic results right now, but I just don't know what the next steps are. So the same for Sri Lanka.
Thank you. I'm going to take a question from the audience. This is coming from Jude Sajid. I'm an undergraduate student who is working on developing a spectroscopy-based diagnostic tool for SARS-CoV-2 by limited resources. I'm stuck in Colombo. It's a lockdown. Will you be able to link me relevant people? So, Mike, I think this is a problem you're trying to solve, but spectroscopy might be the wrong tool, right? I can't hear you, Mike.
Oh, yeah. Well, I mean, spectroscopy is a massive field, right? So we need to be a bit more specific. So I know he asked me a private question. I answered like what methodology, and I recommend he investigate, you know, SARS, surface enhanced Raman spectroscopy. And then he also asked a question about principal component analysis and AI tools. So it sounds like he's pretty well along on his journey of discovery. So what I would add is ask very specific questions. So what can you do in Sri Lanka? You can leverage the resources globally. But when you're mentioning spectroscopy, find one specific modality and focus on that.
Okay, I'll ask the panelists to ask any more questions. We have a few minutes left, so if there's any questions that they want to take, make full use of this panel, because it's not often you get this many brain cells in a single Zoom chat. I'm going to talk about tracer apps, right? Very common, seems like everyone's going for this now. Do or don't, because I feel what happens if WhatsApp gets into this game of tracer apps, and does this have to be a government run thing to enable tracer apps and AI in it?
Well, I think it's going to be community driven, right? So whether the government initiate it or not, problem is people trust the government. I mean, Australian government put in a lot of effort to allay the fears of privacy breach and so on, promising not to access the data, deleting it within 21 days and all that kind of stuff, because the success of this tracing app is basically dependent on whether people trust it enough to want to use it and that it won't be abused. So I think that is the biggest thing again, the whole trust issue and so on. Whether WhatsApp, do you trust Facebook?
My thinking is there has to be one app, whether it's government run or run by the Ministry of Health or whatever it is, right? I'm just trying to, is there, and then there comes instances that we spoke about earlier about crossing borders, right? And this was raised up in the blockchain talk as well. So when you're using this app and say you go into, or if I come to Australia, I want to be able to somehow digitally certify that I'm okay to the Australian government, and then they take over my health from that point onwards once I cross over the border, right? So then that would mean there would have to be some inclination of government or run, maybe possibly not for a startup to get into. So I'm trying to understand what is the economics of getting into tracer apps, because I see a lot of solutions around tracer apps and stuff.
Yeah, I think we discussed this at the blockchain one, right? Because I think one of the best way for private enterprise to do this is to incentivize them, right? Pay them tokens, or basically you mine the tokens when you're sharing the data, regardless of where you are. Then essentially who holds the data? That's the issue here, right? I think that one you need probably a trusted intermediary to develop it.
Okay.
Jivan, there might be another way of looking at it. So one of the winning contestants for the EU versus virus hackathon created some kind of a tracing app. What it is it's web-based, so you don't need to install. You just scan a URL, and what it does is it will tell you if a store is crowded or not. Right, so so maybe as an introduction for tracing apps, you could look at that functionality, and instead of trying to have a global tracing app, focus on specific niche use cases. So what's beautiful about this Hungarian-based solution is there's nothing to install. You just go to a URL, and then the stores that register with this tool, then you get notifications if a store is crowded. Right? So it's not like contact tracing, but why I'm sharing this is something a startup in Sri Lanka could do, right? There's going to be social distancing rules, and you could have automated ways of doing this. Now you can combine this to have a de facto tracing that could still be respectful of privacy.
Okay.
Yeah, I think your question is super interesting, right? It's like we see a lot of these apps, but do they have a life afterwards, right? Can they be sustained as a business?
Absolutely.
And perhaps what Mike was saying is one way, and there I would like to share also, that perhaps companies itself, not just retailers, might be interested to offer these to their customers, but people that need to get back somehow to a factory, they might want to understand better about their people and their employees and their health and support them. So we don't know, like in many countries, this is exactly the moment that the companies are, thinking about coming back to the place of work, and perhaps this could be a way of framing again this tracing apps.
Yeah. Thank you.
There, for example, just a short thought, on, for example, we see these cameras that can detect the temperature, right? And obviously, we usually see it at airports, and we now see it, for example, in Argentina, you see it in different places before a train station and things like that. And you still have people detecting, and analyzing with their eyes whether, oh, they should stop this person. So all this could be even done, automatically with some alarms. But obviously, in the future, that perhaps is even useful, not just in public spaces, but in this more businesses. Yeah. So, yeah.
Yeah.
Yeah, Jeevan, may I say something on that?
Go ahead. Yep.
Yeah. So let me try to turn on my video to see. But yeah, the thing about for contact tracing, I think one of the things you can do is that again use the proven AI technologies like identifying people, right? So I saw that you can do you can install a camera, right, in your company. And you can actually compute the distance between two people. It's essentially a 3D. It's not a 3D camera. It's just a camera, but with AI, you can identify the people, and you can see if they're getting closer than 6 feet away. Okay, and then maybe flash some alarms or something like that. That type of thing is not really that intrusive with respect to privacy, but I think it essentially serves the purpose of warning people to kind of like a fire alarm. In every room, we can put a little camera with the AI algorithm.
Yeah.
That basically warns people to move. If they're getting too close, or if they're getting overcrowded, also to kind of beep at you. Things like that. Some simple stuff I think are completely good. I think we need to use technology, right? Because it's nothing to do with privacy. It's just the way the virus works is that it spreads from person to person, and if you find that you're sick, then you got it from the people who you met. Period. You didn't get it from some outer space, right? So you do need to trace the contacts, but now it's tangled up in this sort of privacy thing. Now, one of the things that I would like to say is that most people don't do kind of secretive things most of the time, right? Basically, they're at home 8 hours a day. 8 hours a day, they're at work. Maybe go to a restaurant for 2 hours in the evening. So, like, you can account for like 20 hours or more of your daily life. Okay, so maybe you can opt in. In other words, I'm saying the privacy violating stuff that you typically don't want other people to know, like which bank you go to or something. That type of thing is you do that only like 10 minutes out of the 24 hours.
Yeah.
So a vast amount of the rest of the day, that you could be giving the disease or spreading it, you can track, and most people wouldn't care, right? Like if you go to a grocery store or something like that, and then come back, then most people wouldn't care that that you were tracked at that grocery store, right?
Yeah.
So I think people will get used to adjustment there, and I think it's a probability to mitigate this thing, right? So it's this proportion of time as well as the number of people you meet. Right?
Yeah.
So I think we can come up with a balance. Thank you.
Very valid points. Yes, thank you for that. I'm just going to ask one more question, and then we'll kind of go into closing thoughts. I think if you look at the journey, we've gone from fighting COVID directly to maybe looking at the post-COVID world to maybe medical and non-medical. So now we're in the non-medical field. So similarly, I think there's a lot of possibilities in solving supply chain problems in the post-COVID world. I think should startups work on in this space? Because I think there's huge opportunities there using AI, blockchain, etc. And I think eventually, though, there might be the businesses who are providing these goods might come up with their own blockchain. So just think about that as well. Mike, do you want to go first? Because I know you're doing some stuff in supply chain and obviously using spectroscopy and supply chain.
Well, we can combine spectrographic fingerprints with blockchain mechanisms in order to provide a robust audit trail, which should actually be closer to HACCP methodology, meaning extending HACCP is a food science methodology for evaluating quality of food with minimally destructive testing. It's a real-time process testing methodology. So we can look at combining spectrographic data with blockchain to extend this methodology to global supply chains. So to get it out of the factory and to make it larger in scope.
Dr. Clarence, any thoughts on that, on supply chain and possibilities around that?
Yeah, again, I think this was raised in the blockchain side of things, where you try to track the provenance of the medication, and also I invested in a company called YPB that is trying to fight counterfeit drugs. Essentially, they coded with it's a technology they acquired from MIT called Motif Micro, where you coat a product with nanoparticles, and then you flash it with your camera phone, and the particles then get activated, and the camera picks it up and then verify whether the product is real or not. So yeah, they're working on so it's nanoparticles. So they're working on some of those solutions that, in fact, the founder. I mean, the reason why I invested in it was the founder actually was in telecommunication, an Australian person, and he was in China when the tainted milk happened. So he was very distressed to learn that all these babies and kids were dying, and he wanted to find a way to prevent that, and that's what led this whole project on. Yeah, so I think very valid there, and it's both ends, right? It's both, again, the validating the supply of the data that you're obtaining, and also the cure, right? Whether the medication that you're providing is what it is supposed to be, the efficacy of it. I think the other thing that we need to understand about the drug discovery process, right? I mean, we are all given medication, same dosage, prescribed, tested on a small population, mainly in the Western world. So how and a lot of times, because we have different genetic makeup, like Vioxx, some of us might have very adverse effects. So these are things that I think, we need to tie in more of the genomics, proteomics, microbiome, and all this other stuff together to see whether the medication that you're providing to people is actually the right dosage or the right prescription that's been given to people, right? Rather than just basically doing what we've been doing, testing on a small population, and then have the whole world take the same prescription. So we got to be very careful there.
Yeah. Any other thoughts, Luciana, Asante? You guys wanna? Okay, fine. I'm gonna then close the panel, and I would like you to leave us with a 2-minute thought on what do you guys see as the biggest opportunity post-COVID, and where should, if you were a new burgeoning startup, what would you look at, and where would you focus your energy? Maybe we can start. Who wants to go first? Take volunteers.
I'll go. I think it's a fantastic opportunity for us to change the whole landscape of drug discovery, right? I mean, as you know, my thought about pharmaceutical industry. I mean, why is it called drug discovery? Could you mute your mic, because I can hear this echo coming back, unless it's a headset. Yeah. So essentially, I think I mean, just like Viagra, right? I mean, sildenafil. It was actually a blood pressure medication, right? But the thing was that, the pharmaceutical economists basically decided that it wasn't worth going to the market, so they canceled the drug trial. All the women gave it back. None of them men did. Then discovered that, oh, wow, this is an ED problem that we can solve. So we don't really know, that's why it's called drug discovery. We don't really understand how some of this medication work. It's all by trial and error. So that's why I think that, now, with the quantum computing simulations and so on, and the opportunity for citizen scientists to collaborate worldwide with, labs that, from databases that Mike and Luciana has been sharing. I mean, there's a great opportunity to uncover a lot of stuff that we don't know about, and perhaps, disrupt positively this whole industry of drug discovery as opposed to drug development, really. I think it's a fantastic opportunity for us to do that.
Great, Clarence. Thank you. Mike?
Uber for healthcare. Okay, we need more healthcare workers. So what we need, what's going to do well is an Uber-like system that fairly pays healthcare providers that are needed in surge capacity situations. So I see, and this is also to localize the healthcare as well. So an Uber for healthcare could also be a way for community resources to be used. Why are you trying to get a nurse from 30 kilometers away when there's a grandma living in the neighborhood that's lonely, that used to be a nurse and would be happy to work 5 or 10 hours a week? So this is where I see there's a golden opportunity. We need more healthcare workers. Let's find ways to get more healthcare workers and engage them in the community.
Yeah, let me, if I may, add to that. I think we can do like an Uber. You can do the Airbnb for the quarantine. Okay, basically, a hospital is too expensive. Sometimes you just need some comfortable place that you can just monitor the people. All right. So I believe that's a good way to go. I want to add, as a finishing thought, from my side at least, the time that you are at home, quarantining. I don't know if you know this, but Isaac Newton, discovered gravity while he was when he was 24 years old. He went from Cambridge back to his hometown to avoid the plague. Okay, so while he went back to his hometown, and he didn't have anything to do, so he was just sitting out, and then that's when supposedly he saw the apple tree and the apple fall. Okay, and that made him think and discover the theory of gravity. Okay, so many of you are at home, kind of probably not knowing what to do and frustrated, but I think take a good example from that. Basically he was a 24-year-old guy, young student, not student, but he was, and then he came back and he became a Cambridge fellow like in 1 year from then, because people accepted his ideas. Okay, so, and he was 25 years old. He went 6 months back to his hometown to quarantine, and that's what gave you the theory of gravity. So I think I can inspire all you guys with that thought. Okay, thank you.
Thanks, Asantha.
Actually, that's not true, Jivan. I mean, because actually it was discovered in Sri Lanka or Malaysia, but the durian or the coconut fell on the guy's head, and he never had the opportunity to uncover it. It's an apple, that's why.
Yeah. Luciana.
Yes. So I see so many opportunities after this situation, that is hard to pick, but I'm just going to focus on two. One, in the realm of health, I think, we can see, and we will see definitely way more distributed health, right? Last week I was, in fact, talking with a startup that is now focused on, let's say, doing a lot of the testing at home, right? I think we're going to see way more of this in general, like, because there is a need, to also rethink the space of the hospital and even all the spaces in our society. What's going to happen with, all these retailer shops that now kind of, so simply just open. Yeah. So distributed health, that would be a space that I would look at. And then obviously learning, which is the area that I'm working on. I truly believe there is huge potential and a huge need there.
Absolutely.
Obviously there is a lot of commoditization, but still that, you know, shouldn't leave us with this feeling like everything has been done. In fact, you know, we see right now that a lot of jobs have become redundant, or people have become totally insecure about their jobs. So how could we, you know, provide people the possibility to reinvent themselves very quickly, to self-learn, to be adaptable beyond just, you know, like a profession that they take or a job. So I think there we have a big opportunity to rethink about that and our relationship to the job, and how do we empower people to create their, to be, you know, to have the ownership to create their future. Yeah.
Absolutely. Thank you so much. I really appreciate the panel for their time. I think great insight and great advice for the startups that's going to come out of Sri Lanka. And the reason participants, why we're doing this is basically to try and build, you know, the next global COVID company out of Sri Lanka. And that's really our aim. And your input has been invaluable for that. So thank you so much. God bless you guys. And I hope to continue working with you all in the future. So thank you so much.
Yep. Thanks, Jivan, for having us.
Thanks,
and
guys.
wash your hands.
Take care.
Thank you.